Well, it's a couple of minutes after. You guys ready?
Yeah.
All right. All right. Well, my name is Andrew Johnson. My company is Logical Helion, LLC, and I'm here to talk to you today about writing distributed processing applications with Helios. Now, Helios is an application that, well, actually it's an application framework that I wrote a couple years ago. I was working at a place, and we had two specific problems that we needed to solve. The biggest thing was that we had to have a way to hand off long-running processes from our website, because there were things that were... Actually, can you guys hear me okay? Or do I need to... Okay. We needed a way to hand off things from our web server because there were things that we needed to do that were just taking too long. And users were getting timeouts. This company had a website that has a social networking component, so one of the things you could do would send messages, except that the network grew so big that if you tried to actually send a message to a lot of people, you would time out waiting for the broadcast to get done, because it was doing a lot of complicated database work on the back end, stuff that the database just couldn't handle fast. It couldn't do it fast enough. Also, along the same lines, there were a lot of things that needed to happen in the background, nightly batch processing, but also updates throughout the day as new information came in. People would have blog posts, people would post in message groups, things like that. But for example, the search engine needed to be updated every so often. The search engine they had before we came up with the solution, actually, they couldn't rebuild the database, couldn't rebuild the search index, and updating the index took 2 weeks to do. So the search index they had was suboptimal, we'll say. But so there was a decision made in particular with that case to upgrade to a Solar index, and there were some other things that were decisions that were made, but the new infrastructure required some kind of way to manage all of this back-end stuff that needed to happen. And at the time, there weren't... Right now, there's a lot of different ways to do this kind of thing, but at the time, there weren't nearly as many, and most of them weren't particularly robust at that point. I mean, this has been a couple years. There's been a lot of changes. A lot of different things have matured. So, there's more options now. But I like this option, which we decided to call Helios. And actually, if you look, you catch that it was originally designed to manage Solar indexes, so Helios. So, okay. Sorry if you don't know your Greek gods. That's that's okay. Anyway, Helios. The goal was to provide a way to distribute the load of massive amounts of work across multiple hosts, but still retain a central command and control option. And ultimately, it uses a collective database to hold the configuration information and the job queuing, and also the default logging. And then, using a standard Unix process model, basically you can use Unix processes and forking and things like that to manage the work coordination and task isolation. One of the goals was, so you have a task, something happens to that, but you've got thousands, tens of thousands, potentially hundreds of thousands of other tasks happening. You don't want that one failure to cause problems with any of the others, which is why the Unix process model actually works really well in this case, because that way things are isolated. Something happens to one, you can throw an exception or handle that. At the same time, you've still got hundreds of others going on their merry way. So the Helios architecture, as I mentioned, has a central collective database that houses the daemon configuration information, the job queue information, and the default logging information. Jobs are submitted basically three ways: through HTTP, and there's a shell script, and of course you can use the Perl API. I'll show you guys the Perl API today, but a lot of times, depending on what you're doing, you can especially a lot of people that are doing a lot of big database work. A lot of times they just need to kick off something. You can just use kick off something from a shell command or a cron or something. That way you can just use from the shell. You don't have to write a special Perl routine just to get things going. Or you can launch a job through HTTP as well. So you don't have to write some bit of Perl in order to get things running. As I mentioned, I've already mentioned daemons. The Helios Service daemons act as agents for your application. Jobs come in, the service daemons see those and launch worker processes. Those worker processes start pulling jobs out of the job queue, and then calling a run method in your Helios service to perform the jobs. Now, as I've already started to mention here, in Helios architecture, there's two basic concepts. There's the concept of services, which is the core of your Helios application. It's just a subclass of Helios Service. There's a run method that you implement. That's the main method that directs the processing in your application. All the processing logic either is in the subclass or can be called from the subclass. So obviously, if you've got a huge library of other routines you want to run, they don't have to be in the subclass. You can just use that module and then make your calls as necessary. When your run method is done, when your job is done, the service marks that job as completed or failed. Now, jobs are just arguments in Helios. A job is just a representation of work. That's a task, a single task, or just a single, like I said, a single unit of work. These are specified via XML. Although it cheats a lot, it's more XML-like. It's not like we're validating against a DDT or anything. That kind of stuff takes too long. And like I said, jobs are arguments only. That's kind of one of the differences about Helios as opposed to some other systems that were around at the time. Jobs aren't code. Jobs are just arguments to services. The code is in the service. And jobs, that way jobs can be really simple and relatively easy to manage because they're just arguments. All your code is in the service. There's a couple other slightly more advanced concepts I'll just mention in passing. I do want to point out that there's a whole lot more to Helios than just these things, but we don't have all afternoon. So this talk is a bit more cut down from a previous talk I did. So I'm going to gloss over some things. If you do have questions or whatever, just feel free to ask, or hopefully we'll have time at the end. Or you can, if we don't have time, you can ask me later. I'm more than happy to talk all day. Anyway, a couple of more advanced concepts is concept of collective, which I'm already starting to mention. Basically, a collective is all of the Helios service daemons that are running and the database that they're connected to. And these are managed by Helios Panoptes, which is the web interface. Basically, as I said, it was the command and control center. You can view logs there, watch jobs come through, view the internal log system, shut down processes, that kind of thing. So Helios has three different basic subsystems. We have job queuing, application configuration, and logging. And as I mentioned already, to create a Helios application, your first step is to create a subclass of Helios service and then implement a run method. And then what will happen is the Helios worker daemon that's loaded your service, when it pulls the job from the queue, will actually pass that queue to the run method. Actually, I should. This looked a little small on the screen, so I'm going to switch over to TextMate. Here we go. Yeah. Now, I'm going to show you a basic Helios service. This is actually in the Helios distribution as an example. It's just a simple thing that extracts the ID3 tags from an MP3 and stores that information in a database. And I'm not going to get into the nuts and bolts of extracting ID3 tags. That's just a module I downloaded on CPAN. But the thing it is, though, is that this does implement the run method, and you can see how basically all Helios stuff gets started. So yeah, we might as well start at the top there. Of course, we're declaring a package, and we're using basic stuff that you do in Perl when you're creating Perl classes. We're inheriting. Here's my pointer. Here's my pointer. We're inheriting from Helios Service, doing a use base. Now, a couple of things here that are Helios specific. We're actually pulling in the Helios error modules, which are some exception classes that Helios defines. Certain Helios methods do throw exceptions, and so it's important to try to catch those. Now, depending on what you're doing, you don't necessarily have to do anything in particular with those. And in writing your own application, you don't have to use these. You can use your own or whatever you want to do. There just are some built-in exceptions here for you to use if you want to. We're also pulling in Helios log entry levels, which is just some constants that help us with logging. That way we can type log info for an info message or log alert if there's a major problem, instead of typing in numbers, because nobody remembers numbers. So that's just some constants to help with logging. And like I said, MP3 info is just something I downloaded off CPAN. It's there for everybody. And then here's our run method. And there's a couple other methods in this class, and like I said, this is in the Helios distribution if you really want to see what they do. I'm just going to concentrate on the run method because this is what's important to all Helios applications. There's a run method. This is a pretty standard instance method in a class. You grab yourself. The only thing that you grab yourself, actually. Anyway, but the only thing that's passed to the run method is a job object, which we're getting there. We'll pull in the configuration by calling the getConfig method, and then we'll parse the job arguments into a hash ref by calling the getJobArgs method. Now, just so you know, this service only actually has one argument. It's a file name, so just for syntax purposes, this is actually grabbing the file name and putting it in the file name scalar there. And then what we're doing here is, this is just straight up Perl. This is an eval to do try-catch type things. You can use try-tiny. I've used it. It works generally well. You could use exception class. It has a try-catch in it. You can use that too. I'm just using straight Perl to just try to limit the dependencies. Just so you know, if you have Perl and a few modules, you should be able to do this. You don't need to use try-tiny or try-catch or anything like that. Though if you want to, you can. First thing you see here is the log message method. That's how you write to the logs. I'll explain a little bit more in detail there in a little bit. But as you see, here's a constant log info. This is just a normal informational message. We got that from log entry levels up at the top. One thing here, we are actually throwing one of the Helios errors here. If we can't read the file name, the file that's specified, then obviously you're not going to be able to parse the MP3 tags out of it. So it's throwing a Helios exception here. Like I said, you don't have to use these. You can have your own, or you don't even really have to throw errors if you don't want to. That's really up to you. Let's see, what else do we have here? We're parsing the MP3 info. Here's another log message. Now there is a concept of debug mode. You can run your service daemons in debug mode. If you do that, the daemon won't disconnect from the terminal. So you can do things like this. If we're in debug mode, actually we're going to dump the data structure that we got back from that MP3 parse algorithm, and that can help ease your debugging. If, say, for example, something is going wrong, but this thing is running over here, and as a daemon, it's hard to get to what's really going on. You can try to log it and things but then that becomes cumbersome. So you can switch things over to debug mode, and then you have access to it doesn't disconnect from the console, so you can watch debug messages come by, and you can do things like this. Dump your whole data structure out and then look at it. Here's another MP3 only method here. We're updating the database, and then once that's done, the job is complete. And so this is what happened. When the job is complete, then what you need to do is call the complete job method if it completed successfully. Now, if something did go wrong, like this error was thrown, or something did happen somewhere else, I've got an eval and eval or do block here. Like I said, this is pretty simple. You can do try tiny or whatever you want here to capture exceptions. I'm just doing the basic thing here. We're grabbing $@ and we're stringifying it and logging that string as an error. And then we're marking the job as failed because it's failed. Failure and succession of jobs will be logged in the job history in the collective database, and you'll be able to see that from You'll be able to see that from the Panoptes web console, or you could actually use SQL commands to query the database and find out yourself. Depends on how much you want to extend the system. You can use the basic system; it works fine, but for a lot of different things. But if you need more things, the database is there for you to query things. Like if you wanted to do reports or something. For example, I've written some applications for some clients before that they needed to see the statistics, like how many jobs were performed in the past 24 hours, how many failed, how many succeeded. You can use everything's in the database. You can write a report on that. Yeah, that's available. All right, like I said, there's some other methods here, but these are specific to MP3 parsing, so I'm not going to really get into that. How are we doing on time? 50. Oh, okay. Let's see. Next slide. Yeah, okay. Now that's how you process jobs. How do you actually get them in the system? Let me switch back over here. And this is actually also in the distribution in the Helios distribution. This is just the little shell script that basically you just pass it in file names, and it submits jobs to Helios to get the MP3s indexed. First thing you have to do is set up the service and get the configuration. This is pretty easy. Basically, I'll explain a little bit about the configuration system later, but once you've got the configuration, then this is just a while loop, while there's still file names being submitted. This is creating XML. It's creating a new Helios job object, passing it the configuration from the service. Set func name, what that does is it tells Helios that, this job needs to be processed by this service. So in effect, even though there's actually one job table in the database, there's actually multiple queues in that table, one for each service. And then we're passing it the argument XML and then submitting the job. And like I said, there's a shell script if you're into shell scripts where you don't have to create Perl stubs or things like that. You can just call the shell script. And there's a CGI in there too if you want to submit things over HTTP. Now, I just want to talk a little bit about the different subsystems a little more. Like I said, about jobs, your run method is going to receive a Helios job object. You use the get job args method to parse the job arguments into a hash ref, and then once your job is complete, you mark it as completed job if it completed, or failed job if it failed. Now the configuration subsystem is a little different than some people expect, because people see configuration and they just think, oh, that configures the Helios service. But it also configures your application as well. Effectively what happens, there's an INI file that you set an environment variable to point it to where that is. And when service daemon starts up, the INI file will have the information, the DSN user password to connect to the collective database, and then once it's connected, then all the other system configuration and your application is in the database table in the collective database. And you can use SQL commands to update the configuration, or you can use the web interface. And then as far as your service goes, to get your configuration, all you do is call the getConfig method, and you'll get a hash ref with all of your application's configuration. So if you've got two applications, like say you've got your MP3 index service, and then you've got something to send out an email or something, those two don't necessarily share the same configuration. You can have that if you want. There is a global section that you can set global options if you want, but it's generally geared toward, each service has its own configuration. And then the logging subsystem, this is something that's actually somewhat new in the latest Helios. You saw the log message method. But and normally, by default, that does write to the Helios database, and that's just a table that you can use SQL to query, or you can view it on the admin console. But the logging interface is actually modularized. You don't have to use the internal Helios log. You can use syslog, you can use log4Perl. Those are out there on CPAN. You can use something else. There's a Helios logger interface that you can use. There's two methods that you have to implement. One to initiate your initialize, I guess, really your logging system, and then a log message method that'll actually be called to write to whatever your log system is. So it's actually pretty easy. So if you wanted to write something for, say, like Nagios or Splunk, you could do that. Although, actually, when I did some stuff with Splunk and actually used log4Perl, so depending on how you want to do that, you can. But the point is that's open. And like I said, if you wanted to only use syslog, you can do that. You can turn off the internal logger, or you can use combinations. For example, if say you wanted to retain the information in the Helios log, so you could do searches on it or that kind of thing, but you had an external monitoring tool that monitored syslog, you could set it up to where your log system, your Helios log system, logs all of your information, but then things of a certain severity, like alerts, or you could even throw an emergency or something, would go to syslog, and then your external monitoring tool would see in syslog, oh, there's an alert. I need to page someone about that. There's two basic design patterns to Helios applications so far. You saw MP3 indexer service. That's pretty simple, and that's a lot of things you can just do that way. Put some things in a class, off you go. More complex apps, sometimes it helps to actually have them be dual-lived, where you can basically develop your app somewhat independent of Helios, and then have your run method act as a main method to call the functions in your application, and then you'd have another method that runs outside of Helios, where you could run things like from a command line. Sometimes that helps testing. I've noticed in developing some of these applications, because sometimes it's because when these things run, they're running from a service daemon. They're not connected to things like standard out, or standard in, standard out, standard error. So sometimes when you're really getting into things, sometimes it's hard to debug things. When you have a really complex application, if you do this way, you do basically have two main methods that start things off. But that way you see something is a problem, you can go to the command line, run it manually, see what's happening there. Of course, in that case, you can also run in debug mode. It just depends on what you want to do. Like I said, for your simple applications, that's not usually something that you do, but these things can get pretty complicated. So there is that option. The basic idea is, to start things with Helios, you start off just subclassing Helios Service, put stuff in the run method, and whatever you put in the run method is really up to you. Now, as far as recommendations for, you've decided you want to try this out, you want to get the most performance possible out of this. Two factors will come into play. One is what your applications are actually doing, and then the other is database capacity. And what your applications are doing is kind of an interesting thing, because a lot of people I've talked to sometimes say, "Oh, well, I can run my thing faster this way." Well, you can run more of them, but that doesn't necessarily mean that you're going to run them faster. If you have 1,000 things to do, but each of them take 5 seconds, you can run 40 of them at a time, but they're all still going to take 5 seconds. So you are bound by what you can do. For example, if you have a file transfer that you want to transfer like all these files and you want to do it all at once. But if each file transfer takes 30 seconds, it's going to take 30 seconds for each job to do that, and you'll be able to do more of them at a time, so you will get done faster. But you still do have, there still is a certain thing there where you're not going to get faster than what its theoretical limit is going to do. The other thing, as far as Helios is actually concerned, is database capacity. As I mentioned, the job queuing, the logging, and the configuration is all in a database. Obviously, Helios can work faster than if it has a larger database. MySQL, you can do a lot of interesting things with MySQL. I've seen MySQL scale much higher than I thought it would, actually. The company I worked for when we originally wrote this had a relatively beefy MySQL server, but it wasn't really, wasn't that much involved in like tuning. We didn't have like the cluster stuff. It wasn't like it was nice, but it wasn't anything out of the ordinary. And they were able to do, I think last time I talked to them, they were doing something like millions of jobs a day. So, of course, a lot of that was bound by what they were doing. Sending mail takes time. File transfers, they take time. One thing that's new, that's pretty much brand new, is official Oracle support. I do have some things running on Oracle RAC. It is actually impressive how far Oracle can actually scale with RAC. I point out this is still kind of beta, mostly because the web admin interface Panoptes actually hasn't been updated for Oracle yet. Only the core Helios is running on Oracle right now. So requirements to get this thing running if you want to try it out. Basically, any Unix OS that's running Perl ought to be able to work. As I mentioned, MySQL or Oracle. And you'll need a CGI web server if you want to submit jobs to HTTP or use the admin interface. I'm going to go ahead and list a couple of major CPAN modules here because sometimes people have I'm sure actually we've all ran into this where, oh look, I want to use this, and then you go to the CPAN command line and you type install something, and then there's 10,000 things that get downloaded and run, and then number 500 something dies, and it's like, oh no, now I have to. I'm just warning you that these things are here. There are pretty extensive install instructions in the distribution, but just fair warning. Data Object Driver and the Schwartz we're relying on to do some job queuing and some database work. XML Simple is doing the XML parsing. There's config INI files there. I point that out. That is not supposed to be a particularly annoying module, but it has been on Perl 5.8 lately because it wants to install a bunch of stuff it didn't used to do. But so I'm just pointing that out if you are actually going to run it on 5.8. And then the error module. Error Simple is used as the base exception class for the Helios classes, and I'm pointing that out because the error module got a lot of flack for its try-catch methods, and that that was warranted because you effectively you could accidentally create closures, so that's bad. But error simple is a simple base class for exceptions that is in there that doesn't do crazy things at a glance. So we're still actually using error simple as a base class, but for the exceptions, we're not using the try catch things that are in there because that ends up creating some problems. Having said that, though, as I mentioned, you don't have to use that. If you want to have exception class or something else as your exceptions, that's fine. Actually, apparently a talk that was parallel to this one was about a new exception system. So I'm sorry you guys missed that, but I'm glad you came here anyway. So future roadmap, where things are kind of going with Helios. As I mentioned, things are somewhat database bound now, and one of the things is really want to start trying to modularize Helios more, simply because a lot of people don't have that database infrastructure built to be able to take advantage of this. So one of the things is to modularize the job queue, so you can use things like RabbitMQ or ZeroMQ. Eventually like to provide job argument support in JSON. So because a lot of people do have JavaScript, and they want to, rather than go through a CGI, they'd like to be able to just use JavaScript and submit jobs, or submit jobs from Python or something else. You could also do complex job arguments there too, which is something that the way that Helios is using XML simple right now, it's really not geared for doing complex data structures right now, at least not. You could do it, but that's the thing. You'd have to sort of grab the job XML from your job object that you were passed and do special things to it. You couldn't just use get job args and get your complex data structure back. So I'd like to add JSON support for that. And then also, as I mentioned, the error module is a little out of favor now, so eventually I'd like to move to exception class. Although, as I said, none of this is actually preventing you from using your own exceptions. It seems like Perl, not only is there more than one way to do it, there's definitely more than one way to throw an exception and catch it. So just because Helios is using error simple doesn't mean you have to. And like I said, ultimately what I'd like to do, the logging system, modularizing the logging system has really opened up some opportunities for certain clients and some other people, just that flexibility. And I really see that increasing the modularity, I think, would really increase the niche that Helios can service. So as far as you heard all that and you're still interested, Helios is on CPAN, and the Panoptes web interface is packaged separately, but it's also there, as well as the two logger classes for syslog and log for Perl are there too. Like I said, you could use whatever logging system you wanted. Syslog and log for Perl seem like fairly popular ones, but it's relatively easy to write your own. I'm LAJ Andy on CPAN, and you could contact me through my CPAN address if you have any questions or any ideas. Any patches are also welcome. And then, as I mentioned, my company, new company, so it's still a little bit rough around the edges as far as website and things like that, is logicalhelion.com, and it's also logicalhelion on Twitter. So, questions? Anybody? Comments? Snores. Yeah, the question was, have we thought about what's his name?
Thomas Duran. I assume I'm pronouncing his name.
Okay.
This morning about
Okay. Well, that is one of the things with the modularity. If we open things to the point to where you could pretty much just use whatever job queue you wanted, then you could use that one. Or I mentioned RabbitMQ because that's a really popular queuing system right now. The Ruby people especially are using it a lot, and so that seemed to be a good target, initial target. But yeah, pretty much the idea would be to make, like the logging system, the logging API is generic enough that you can pretty much put just about any logging system in there, really. Same thing. What the goal really is to make the interface generic enough that whatever queuing system you want to put in should work fine. For example, one thing I noticed this past week is, what's the name of it? Directory queue is on CPAN. And that it actually uses the file system as a queuing interface. At first, you kind of think, oh, well, that seems awfully simple. But that's the thing, though. It's awfully simple. That's a great first step to get you started. And then if you go beyond that, then yeah, you can replace that with RabbitMQ or something like that. So the goal really is to be able to write your Helios application, and then be able to change the queuing system, the logging system, whatever underneath, and not have to change your application, because Helios will handle all the job stuff for you, all the queuing or whatever, and then you don't have to worry about that in your application, because your application just calls the Helios APIs, and Helios is handling that under the hood. So I didn't see his talk, but actually I'm interested now. I'm going to have to go back and check his video. Anybody else?
Is there a requeuing of the job so the job fails?
Yes, actually there is, and that was one of the things that I had to cut out, because last time I talked, my 50-minute talk was about an hour and a half. Yes, there's an API that you can do. See, the Schwartz actually handles that underneath, but there's a few things that it doesn't do quite like Helios wants, so Helios kind of has a bit of a shim API over it. But and there's a few changes, well, not changes, but enhancements I want to make soon to that. But yes, in your service class, there are two methods you can define, a max retries and a retry interval method. And if you do that, then that sets how many times a job is retried if it failed, and the interval of that, how many times, the interval between retries. Now, like I said, right now Schwartz is actually locking the retry interval to a minimum of 60 minutes, which is weird, and hopefully Helios in the near future is going to change. I have something I'm testing now to change that to where if you want to retry every minute, then you can do that. It's one of those things that you have to be careful about to make sure that things work all right. I should note too, in addition to the fail job method, there's also a fail job permanent method. If, for example, your code threw an exception that for some reason you decided, no, I don't want this. Don't even try. Just stop. So yeah, you could, if you threw that exception or for some reason just decided, no, we're stopping with this altogether, do not retry, you can call that method, and the job will be permanently failed, and it won't appear in the queue again.
Sort of going along with that, what happens if a job never returns?
Never returns?
Yeah.
What do you mean?
Well, I don't know. You send out a job to a computer and
Well, okay, so... Oh, I just realized I haven't been repeating the questions. Sorry about that. The question was, what happens if a job is submitted, a service picks it up, worker process picks it up to do it, and then crashes for some reason? Okay. Well, one of the new things in Helios 2.4 actually is there's actually extra error trapping that happens. So if for some reason your code dies of an uncaught exception, Helios by default will capture that and log that and automatically fail the job and log that as an uncaught exception that you should probably fix. But so there is that extra error trapping that's there now that wasn't there in the previous versions. Actually there's a configuration option to turn it off if for some reason that's complicating your stack too much or something. But if that were to happen, the way Helios works, when the worker process gets the job, it's actually locked in the database for a certain amount of time. If that job isn't marked as succeeded or failed after for that amount of time, after that, the other service daemons and worker processes see that job as fair game. And so after that time is expired, another worker process will pick that up. And but of course, that's part of the thing. Helios tries its best to prevent that kind of thing from happening, but or at least now it does anyway. But if it does for some reason, another service would pick it up eventually, and a worker process would pull it from the queue. Yes.
Similar to that, so what happens if I send out a job, and that job, for whatever reason, gets stuck in the loop and just never returns? So that not make all those other service daemons also get stuck in the loop when those other services try to go grab that job?
Yes. Okay, so the question was, what happens if a worker process picks up a job and then gets stuck in what appears to be an endless loop, never marks the job as failed or succeeded, and then other processes also come along and pick up that process and also get stuck in an endless loop? Well, yes, that is something that can happen. Basically, after the job lock interval has expired, basically when worker processes pick up a job, they are locked for a certain amount of time. The default is an hour, I think. I'd have to go back and look at the code now, but I believe wait, what time is it? Okay, we have a little bit of time, right? Yeah. So, yeah, when worker process picks up a job, it is locked for a certain amount of time. And like I said, I believe it's an hour right now by default. So what happens? The process gets stuck in an endless loop. So then that hour expires. That process is still working there, and then another process comes along and picks it up. Also gets stuck in an endless loop. Okay, yes, that's a problem. And one way that you can deal with that is there is a configuration option for Helios processes called, is it worker max TTL or is it worker max TTL? That after a certain amount of time, if a Helios process has gone a certain amount of time, basically what you do, you set worker max TTL for a certain number of seconds. If a worker process runs beyond that certain amount of seconds, Helios actually kills that process. So that doesn't necessarily solve your problem, but it does prevent things like that from spinning out of control to where suddenly all of your worker processes are all stuck trying to do the same job, and the queue is backing up because there's no longer any processes available. So you can set the worker max TTL to forcibly kill off processes that go for too long, because a normally working process actually checks that every so often to make sure that it's not been running too long, and if it goes past that it goes past that number of seconds, it'll shut itself down. So the Helios Service daemon is watching the processes. If it sees that a process has gone on for too long and hasn't shut itself down, it has to assume that something like that has happened, that there's an endless loop, and it kills it. All right. Any other questions? Looks like we're starting to get some people in for the next presentation. Anybody else? Okay, good. Well, I'm here till Saturday anyway. I go on at length, as many people will tell you, about Helios and other things. So I am more than willing to talk to you guys, especially if you have like an app in mind that you think Helios might be good for. I'd love to talk to you about it. So, So thank you for your time. I appreciate it.